What a simple fishbone diagram could look like in our subsequent example is something like this. To identify which overarching factors to prioritize, the diagram can be formed by a powerful hypothesis test like ANOVA to empirically or statistically determine factors that significantly contribute to the problem. So in this example, we are given a call center data, as mentioned before, with the call center location, type of request, the date of the call, the call wait time, customer categories, the week, hour, and day of the call. Now, to start, let's first create a unique ID to serve as references to these calls. So let's just type here ID. And then under ID, let us concatenate the columns call center, request, dates, durations, customer category, hour, and day. Now notice that I excluded the column week. And the reason for that is that for all of these records, the week is just week 36. So all of these calls happened within the same week. Now, suppose we want to confirm whether the type of request is a significant factor in driving long wait times for the call center of the company. So to do that, let's first highlight the entire table, go to Insert, Pivot Table. Then for this option, let's just change the location where we will place the pivot table from new worksheet to existing worksheet. Then let's click on this button here and say, let's put it here in the first cell under L. And click OK. So now that we have a blank pivot table here, we'll need to drag the ID to rows, and then the factor that we want to examine or investigate against our outcome of interest, which is call duration. So say we want to investigate request type. So let's drag request type to columns. Now for durations, this is our performance measure of interest. Let's drag this to values. Now the default aggregation in the pivot table is sum. So let's change this aggregation by right-clicking on any value inside the pivot table, then going to summarize values by, and then ticking average. The reason why we changed the aggregation from sum into average is because in ANOVA, we want to confirm or test whether there is significant differences between the averages of the different groups. So now that we have the base data set that we'll need to perform the ANOVA test. So let's now go to data analysis, and then look for ANOVA single factor. Click OK. For the input range, let's click on this button and then highlight everything from credit cards to technical support all the way down, excluding the grand total row. Let's retain the option columns here and make sure that we tick this option here because we selected the column labels. Let's also retain the 5% level of significance here. And then for the output options, make sure that output range is selected. And then let's click this button here and place results of the ANOVA test here. Say U1. Then click OK. So as you can see here, we have the different request types for the different call centers. We know how many calls for each type of request or each type of call, the total duration for all the calls, as well as the averages. Now, the p-value for the ANOVA test is notably less than 5%. So it's very near 0. So that implies that the type of request has a significant influence in the duration of the calls or the call wait times for the financial services companies' call centers. So if we go back to our fishbowl diagram shown earlier, now we can definitely include the type of request as one of the significant overarching factors or categories that we can further drill down into. You may also replicate the same process for the other factors that you have in this data set, say location, or the time of day, or the day of the week. So once you confirm the factors for which the p-value is significant for the ANOVA test, then you can now share these insights to the company, and the company can take the next step and begin to investigate why issues in these broad categories or result areas exist and how to fix them.